Who's in the room? Location and test. Hey Cody, how you doing, buddy? Can you hear me? Okay. Great, great, great. Okay. Okay. Let's start firing those questions away. All right, I'm just checking for questions at this time. A question came up this week about circuits, electrical circuits, and there's two types of electrical circuits. As far as the testing goes, you'll pretty much see two types of circuits. You will see a series circuit. Sometimes they won't even have a power source. Let's go to darker. Sometimes you'll just have two connecting ports like this. And you'll have a connection like that, and you'll have components, maybe resistors. So that's 2 resistors, 3 and 4 resistors. Now, here's the start of the circuit, and then here's the end of the circuit. So it's one device or component connected after the other. So that is the series circuit. All right, you could also have a parallel circuit where, in this particular case, how they draw this out. The components are connected. All right, so there's more than one electrical path for electricity to flow. All right, so a series circuit, it probably wouldn't look like that. Let me give you another way it would be drawn out. Now, primarily you'll have a power source in this circuit, and you'll have a power source on this circuit. Now, the series circuit will be like that. So you might have, I don't know, a resistor, you may have a light bulb, but there's only one path for electricity to flow as opposed to the parallel circuit. And maybe you may have a resistor here and a resistor here. But the difference is that there's more than one electrical path as opposed to just one. So series and electrical circuits was something that came up this week. And if you're in the room, just type in your name and location. We had another question come up today. Let's see. Okay, so the question goes as follows. There is a ground surveillance radar setup that can detect moving individuals out to a radius of 10 kilometers. So we have a radar, we have some type of movement detection system that can, I'll put the little radar thing. All right, it can detect moving targets at 10 kilometers. All right, and the radar covers a 36-degree segment. So let's just say this is 36 degrees here. All right. And the question continues, how many kilometers of area will it cover? All right. Now, I know this looks a little hard, but we got to keep in mind this radar reaches out 10 kilometers at a 36-degree angle. And we want to know the area that it covers. Now, it might look a little challenging at first, but it's really not that bad. Our answers are 6.28 kilometers, 12.56 kilometers, 31.4 kilometers, 62.8 kilometers, and 360. And actually, this is square. All these are in square kilometers. So I'll just put an SQ on the top. Now, most people look at this and be like, oh man. But if you think about it, it's really not that bad. If you think of a whole circle, this is only covering 36 degrees. So this is actually 1/10 because there's 360 degrees in a circle, and that's why it's 1/10. So if the radius is 10 kilometers, then all we have to do is figure out the area for an entire circle with a radius of 10 kilometers and just reduce it to a tenth. And then we have our answer. So 6.28, 12.56, 3.4 square kilometers, 62.8 square kilometers, and 360 square kilometers. So now, what is the formula for the area of the circle? Formula for the area of a circle is pi r squared. Now the cool thing about this is 10 is the radius. So pi times 10 squared, and 10 squared is 100. So we have 100 times pi, which is 3.14. So if we have 3.14 and we're multiplying by 100, and I think I may have written this there. All right, 3.14 times 100 is going to be, we're going to move this over 314. All right, and then if we want 10% of that, if the decimal's here, making sure we're getting all of this on the screen. All right, if we want 10% of this number 314, and all we have to do is move the decimal point over once. So the area that this covers is 31.4 square kilometers. All right. And if that's clear, just type in clear, guys. So to recap, our question says a ground surveillance radar set can detect moving individuals out to a radius of 10 kilometers. If the radar is used to cover a 36-degree segment of a circle around the radar, how many square kilometers of area will it cover? All right, so we realized that 36 was 1/10 of a full circle. 36 degrees, 360 degrees will be the full circle. So we calculated the area of the entire circle with a radius of 10 kilometers. After we came to the conclusion that the whole area is 314, then we just divided by 10, or found 10% of the circle, which is this shaded area, 10 kilometers at 36 degrees. So our answer is 31.4 square kilometers. And if that was clear, somebody type clear. And how's my video coming in? And audio. Okay, great. So I thought that was a really good question. And we'll check in the email for more. And guys, don't hesitate, send them in. Looking for something interesting. In there. Another question, and I said I was going to start doing more and more questions pertaining to the SIF test. A big question that we covered this week for you SIF guys is you're going to have a good understanding of aerodynamics in rotary wing aircraft. And today we came across a subject called dissymmetry of lift. This is for my SIF guys. Dissymmetry of lift. Now, we kind of touched on this a little bit. All right, so we have our rotor hub. And here's our main rotor disc. Rotor here, rotor here. Now, dissymmetry of lift occurs when we start moving the helicopter in forward flight. So let's make our little cockpit and windows, and we're looking down at the helicopter. Then we have our tail boom, and then we have our tail rotor. Now, we split this main rotor disc in half, and we have a advancing, let's say we're moving forward at 120 knots. Well, the whole aircraft is moving at 120 knots, but if we think about this hub as being the aircraft and it's moving 120 knots, as the main rotor swings forward, it actually moves faster. So let's just say the outer part of the main rotor tip moves forward at 480 knots. All right, 480 is actually the speed of the tip of that main rotor. So we have an advancing blade, and it's still moving at 480. That is the retreating blade side. Okay, so advancing, moving forward, retreating blade moving backwards. And then we get a dissymmetry of lift, which means we're going to get more lift on one side than we are the other. So if we think about it, while this is moving forward and we have 120 knots, this actual main rotor at this point from 6 o'clock to the 12 o'clock position is actually moving at 600 miles per hour. All right. And when it swings this way, it's moving, it's kind of being counterbalanced by the forward motion. So let's see, 480 minus 120, 360. So it will be moving backwards at about 360 miles per hour. The object of this is that we're going to get more lift on one side. Which side are we going to get more lift on? And a little crowd participation on the advancing blade side or the retreating blade side. And just take a stab. The advancing side, very good. So on the advancing side, we're going to get more lift. So if we get more lift on this side, then what it's going to want to do is turn the helicopter to the left. And so we're going to have to apply a little bit of right anti-torque pedal. All right. So that is dissymmetry of lift. That is something. And in the helicopter flying handbook, the first 4 chapters, if you're going to take the SIF, you're going to want to know the first 4 chapters like the back of your hand. So every week I definitely want to do something for the SIFT guys. Okay, this is really big. All right. Okay, this is an interesting question. Sue and Joe are on opposite sides of a circular lake that is 1,260 feet in circumference. So the distance around the circle is the circumference. They walk around it starting at the same time and walking in the same direction. So Sue walks at 50 yards per minute and Joe walks at a rate of 60 yards per minute. So how many minutes will it take Joe to overtake Sue? Ooh, that is an interesting one. I don't know if I'll be able to solve it. So this is a little bit of a toughie there. All right. So when we see word problems that we're really not familiar with or we're not really sure of. Okay, so what do we know? We have a circular lake. Let's put our little sailboat in there. All right. A little bit of water. All right. So we have a circular lake. The distance around this lake is the circumference, which is 1,260 feet. They walk around it, starting at the same time and walking in the same direction. All right, so let's just put it here. And this is the starting point. So we have Sue and we have Joe. And she walks at a rate of 50 yards per minute. YPM, yards per minute. And Joe walks at 60 yards per minute. Yards per minute. In how many minutes will Joe overtake Sue? This is kind of starting at the same time and walking in the same direction. Sue's walking at 50 yards a minute, and Joe walks at a rate of 60 yards per minute. In how many minutes will Joe overtake Sue? Well, if they're starting at the same point at the same time, immediately he's walking at a faster rate. So this sounds like a trivium question. Trivium is going to get me. I'm going to be at their office. They're going to have my face on a wall throwing darts at it. Keno doesn't like our book. I mean, you guys, I wish I could post this, but Sue and Joe are on opposite sides of the lake. Okay. See, that's why you got to read. They're on opposite sides of a circular lake. All right. So Sue's on that side, which makes this harder. All right. Joe is on this side. And he's walking at 60 yards per minute. All right. Line by line, folks. They start at the same time and walk in the same direction. All right. So let's say they're going counterclockwise. All right. And so the question is, how long is it going to take Joe to overtake Sue? This is kind of crazy, but I got to think of this as like, it's not a delayed departure question. It is I'm thinking of this as it's weird. I'm thinking somewhere around 300 yards they should meet. And I'll tell you why I think that in a second. But when you see something like this, and our answers are 14, 21, 28, 35, and 42. These are all minutes. 14, 21, 28, 35, and 42. All right, and let's just say in yards per minute. All right. So that means in 1 minute, Joe and Sue. So in 1 minute, I'll make a table. We're going to be at 60 after 1 minute. Sue's going to be at 50. In 10 minutes, this person should be at 600 yards, and this person should be at 500 yards. So, wow, 1260 divided by 3 is going to give us yards around the circumference. This is really tough. 4, 12, 0, 6, 6, 2, 420 yards. 420 yards is the distance around. So, let's think about this. 210 yards is the halfway point. So, she has a 210 yard head start. So, in order to catch up, I'm going to have to match and then gain 210 yards. All right. This is tough, man. All right. I've never seen a question like this, so I don't really have a formula that I can think of right off the top of my head. So in 10 minutes, Joe covers 600, Sue covers 500 yards. Wow. Any ideas, guys? This is tough, and I don't have a formula. So it is a very good question, though. It is a very good question. I'm trying to think. All right. So in this case, I'm gonna just take a stab here and see where things match up. So let's take both of these in 14 minutes. All right. In 10 minutes, yeah, I'm gonna have to do some research on this, but that is a damn good question. Wow. I don't really get too many questions that sit me down, but this one has definitely done that. And I'd like to get into it, but it is probably going to take a longer time. But feel free to jump in, guys, because I'm at a loss. So, I don't know. Let's just see. Let's think of it in terms linear, not so much a curve. 60, 50. So we established in 10 minutes, at the 10-minute mark, we're going to be at 600, and then this person will be at 500. And in 20 minutes, 1,200 and 1,000. But in 10 minutes, no, between 10 and 20 minutes, I believe that this person will have not only moved the distance, but remember, they had a 200-yard head start. So in between 10 and 20, I would go with, well, 200 yards. 200 yards. So, which means that they both, I'm going to go with 21. Final answer. The reason why I say that, because I'm looking at 60 and 50, right? And although I can't determine the correct amount of time, I know that when it occurs. So this person, Sue, has a 210-yard head start. And so this means that Joe has to not only move the same amount of distance, but also cover that extra 210 yards. And I believe it will occur around 21 minutes, because in 10 minutes, he moves 600 yards, she moves 500. In 20 minutes, he moves 1,200 yards, and then she moves 1,000. So that they both move 1,000, but not only does this guy move 1,000, but he also moves almost 210 yards, which is 200 yards. So I believe in another minute, I'm going to go with 21. What is the answer? That came from Cody. "21 minutes." I got it. I got it. But do you guys see how I just kind of, I said, you know what? Throw the circular motion out the window. Just throw it out. We just understand that Sue had a 210-yard head start, because I took this, I divided by 3, and that gave me yards. So I know that 420, half of the distance, because they're on opposite sides of the lake, is 210 yards. So then I had to just, and you're going to have to do this on the test. Sometimes you're like, damn, I don't have a formula. But mentally, you're going to have to think through it. I was actually about to, you know what, boom, never mind. But then I jumped back in the fight. So I said, okay, well, let's just take a look. Let's just look at the two distances, how much they'll travel. So I tested it. I saw how many yards they would move after 10 minutes. And then I looked at 20. And then I understood that not only does he have to cover the same distance to overtake her, but he also has to compensate for that 210-yard head start. So around 20 minutes, according to our table, he covered the 1,000 like she did, plus 200. So that happens at 20 minutes. So the closest answer is 21. And type clear if you understand my reasoning behind that. That was tough. Oh, Cody, that was tough, man. You know what? Stop that. It's too late for those type of questions. No, I'm kidding. It's all right. Send them on. All right. Great. Why'd you say dang, Osvaldo? Yeah, that one was challenging. Challenging is not the word. Yeah, it was crazy. But sometimes you got to think outside the box. Get away from the circle and just think in a straight line or linear distance. And that's what I did. I said, you know what? Forget this circle, because I don't have a formula for it, and it's throwing me off. So I just looked at distances and see how much distance are they both going to cover after 10 minutes, how much distance are they going to have to cover after 20. So I think you guys all got that. And I think I beat the explanation to death. And hit that like button, because that was work. This is a free live stream. Woo! I should be working that hard. Whatever happened to the distance, rate, and time questions? And in a sense, that is the distance, rate, and time question. But wow, that was like boom. And I feel like Kobe Bryant in the fourth quarter with 10 seconds left on the clock. Uh-oh, sports fans probably hate the Lakers. I'm not a sports fan at all, so. But when I think of a great ball player, I think about Kobe. All right. Hey, hit that like button. I earned that. I should have earned everybody's like in that. And had one question, I should have everybody's like. Seriously. That was super tough. Let's see here. All right. No, let me have it tonight. Okay. Morton is the last name. Welcome to the room. I didn't recognize your name, Leon. I see you in the room. Good to see you back. And guys, type in the test you're preparing for and your location. Please. I just like to see where everybody's from. And who I could hate on for having really, really good weather. Because in the Northeast, the weather sucks right now. It's so cold. You guys down south is like, oh man, it was a cold day. It was like 30 degrees. We are praying for 30 degrees. Mark 8790. All right, welcome to the room. All you newcomers, I'm here every week. The best way to get the most out of the live stream is find the questions in your book that you don't understand and bring them to the room. Okay. Yeah, Julie, I'm hating on you. Sunny and beautiful. Leon, I'm hating on you too, Pensacola. I know it's probably a little chilly down there, but not as chilly as it is here. So, no, I'm not really hating on you guys. Yeah. But no, I just wish it was warmer. I think we're in our single digits. I saw somebody on my Facebook say, what'd they say? They had like a meme when it was like single digits. It was like the first person that says it's too hot, I'm punching in the face. It was 4 degrees that night. You know, when the summertime comes, they were saying, okay, the first person said, it's too hot. Because that's what people do up here. Oh, it's too hot up here. It's too hot. It's too muggy. But just stay hydrated. You're good. All right. One thing I noticed is that a lot of people have really been missing the boat when it comes to the 3, 4, 5 right triangles. And what they do is they'll have a triangle that they don't see as a 3, 4, 5, and then they start using the Pythagorean theorem, which is okay. But the tests that we are preparing for, guys, are time sensitive. And so when you have areas that you can capitalize on, then you should capitalize on them. So the kind of triangle I'm referring to is a 3, 4, 5, meaning one side of the right triangle is 3, one side of the right triangle is 4, and the hypotenuse is automatically 5. Now, there are variations of this triangle, which means like, okay, let's say this is 60, right triangle, and this is 80. All right. So 60 and 80 is a variation of the 3, 4, 5 triangle. And I know that the hypotenuse is automatically 100. Automatically. Based on the 3, 4, 5 triangle. Because I see the 3 times 20 is 60. 4 times 20 is 80. So 5 times 20 is 100. So automatically, it should take you no more than 3 seconds when you see a 3, 4, 5 triangle. Another way that they could present this is you got 2 cars. Car 1 It doesn't look like a car. Don't laugh at my artwork, guys. Don't laugh. Sensitive. In car 2, this guy goes 120 miles east, and this guy goes 90 miles north. All right. And then after they travel the 90 and 120 respectively, it's going to ask you, well, how far are they apart? They're 150 miles apart. Because that is a 3, 4, 5 triangle. They're giving me the 3 and the 4, and the way that they're telling me it's a right triangle is because this person goes north and this person goes east. All right. So the 3, 4, 5 test makers are very lazy. They use all these tricks like 3, 4, 5, and I can make a million questions off of 3, 4, 5. I could use 6, 8, 10. 6, 8, 10. I could use, I don't know, 300, 400. That makes the hypotenuse 500. I could do 3,000, 4,000 for the two sides, and then 5,000. So when you see these questions, capitalize off of them. You kill them and you keep moving, and you walk away knowing, I nailed that. And you made your points and you keep moving. All right. So even still with a lot of new people that are like, yeah, I watch your videos and, I want you to help me with the FOQT or this or whatever. Then when I meet them, oh man, I watched all your videos. No, you haven't. Because you don't know about the 3, 4, 5. If you actually watch my videos, you would know about the 3, 4, 5. How many people in the room remember me talking about a 3, 4, 5 triangle? Just type in me. And if you haven't, don't worry about it. Nobody's going to point fingers at you and go, oh, you weren't paying attention. But, I talk till I'm blue in the face about this 3, 4, 5. Boom, you see that? Cody, Osvaldo, they've been with me for a little minute. Osvaldo longer than Cody, but the 3, 4, 5, it's so easy. Now I think because I prepare people for this test, to me it just jumps out at me. I'm like, I'm like on a horror film or something. Like, oh my God, 3, 4, 5. But there are many variations of the 3, 4, 5 triangle. I can make a million test questions off of it. As you can see, 3, 4, 5, 6, 4, 10, 300, 400, 500, 3,000, 4,000, 5,000, 60, 80, 100. Which this is one of the assessment questions that I use. It's kind of worded a little bit differently, but 3, 4, 5, guys. 3, 4, 5. Okay, checking the email. Okay. All right. This is an aerodynamics question or airplane question. And the question is just asking, when is an aircraft in equilibrium? I think that's a SIFT. That could be ASTB as well. Aviation Selection Test Battery question. All right. When is an aircraft in equilibrium? Now, primarily, since we have SIFT guys that come here or visit this channel as well, I'll do both. So we'll have our little airplane. And we will have our helicopter. There's our main rotor. Okay, now, two different aircraft. And we have an airplane to the left and a helicopter to the right. All right. When is an aircraft in equilibrium? All right. Well, the aircraft is in equilibrium when we have lift, weight, and notice that the vectors are about as close as I can get them. All right. as far as even, because when we make vectors, we want them to be like even or the same amount of length to show that they have the same amount of magnitude or strength and direction. They're opposing each other. So this is thrust, sorry, and this is drag. All right. So the airplane is in equilibrium when lift is equal to weight and thrust is equal to drag. What does this mean when this aircraft is in equilibrium? It means it's not climbing, it's not descending, it's not accelerating, and it's not decelerating. It is at a constant speed. So on your airspeed indicator, when it's reading, I don't know, 250 knots, the needle's not moving forward, speeding up, or moving backwards, slowing down. And the altimeter is not moving. The altimeter needle is not moving at all either. So you don't see a climb or descent on your altimeter or vertical speed indicator. For a helicopter, it's the same, but kind of not. And I'll explain why. For the helicopter, we still have lift, but this is actually thrust, right? From the main rotor blade. And then this is the weight, all right, for you SIFT guys. Now, the thrust is being produced by the main rotor blade, taking the weight off of the main, the skids or landing gear of the helicopter, and it's keeping it up. Now, in hovering flight, you don't have any vectors. You're not moving forward, you're not moving backwards, all right? So, right now, this helicopter is in equilibrium, all right? But when we push the cyclic forward, then the helicopter is going to tilt forward, and it's going to move forward. So it's actually going to produce a thrust vector at that point. But right now, this helicopter is in equilibrium because it is not moving, and the thrust or lift produced by the main rotor is counteracting the weight of the helicopter. In the aircraft, we're in equilibrium when thrust equals drag and lift equals weight, which means we're not climbing, descending, accelerating, or decelerating. So I hope that was clear. Alrighty. And oh, this is a good one. This is a good one. Good mixture of questions, though, guys. Appreciate it. It just makes the live stream look that more interesting. Okay. This is a test question that has been seen on the Aviation Selection Test Battery, as well as the United States Army SIFT. All right, so it is just something that you may need to know. All right, now I've seen this question presented in two ways, where they said we have a balloon, right? And in each case, this balloon is filled with the same gas. All right. Now, the balloon's filled with the same gas, but you notice that they're bigger, which means that the molecules inside of whatever that gas is has pushed the balloon outward. All right. So, what it's saying is that, or what the question asks, how was it worded? Which balloon has the most pressure exerted on it? All right, so which balloon has the most pressure exerted on it? And another way, it will say, which balloon is at a higher altitude. Higher altitude. All right. So the question has been asked more than one way. Which balloon has the most pressure exerted on it and which balloon is at the higher altitude. So when I look at this, I'm thinking of atmospheric pressure. Atmospheric pressure at sea level, the atmospheric pressure is at 14.7 pounds per square inch. If we took a square inch cube and trapped air at sea level, that's how much it will weigh, 14.7 pounds per square inch. Now, I don't have a standard atmosphere table, but let's just say for giggles, we climb up to about 20,000 feet, and we would have 7 psi, all right? And at 20, the standard atmosphere is not 7 psi. All I'm doing is demonstrating for my trolls that, like, look, is that we have less atmospheric pressure at 20,000 feet than we do at sea level. That's all I'm saying. This is not the correct number, but I'm just trying to demonstrate that 7 psi. And then now that I think about it, I think it's probably around 7 psi at 36,000 feet. I think. Don't quote me on that, but I'm just letting you know that there's less pressure at 20,000 feet. So since there's less pressure, less force is atmospheric pressure is going to be exerted at 20,000 feet. So the internal pressure is going to build, and it's going to push the balloon. It's going to make it bigger as long as the material is there, which is rubber probably, and it will expand. So which balloon has the most pressure exerted on it? It will be the little guy. He has the most pressure exerted on him. The balloon at altitude or less pressure, higher altitude, 20,000 feet, is going to be this guy. That internal gas is going to expand. All right, so this test has been coming back on debriefs a lot. And so, and the person that debriefed and gave me this question, they did answer the question right. But there's two ways they could ask. Which one has the most pressure exerted on it, or which balloon is at the highest altitude? This will be the one at the highest altitude, or has the least amount of pressure exerted on it. The smaller balloon will be at the lower altitude and have the most atmospheric pressure exerted on it. Okay, so we got another live stream down. I'd really like to thank you guys for taking time out. You guys could be out partying, drinking, eating hot wings, which I'm about to do tonight. I'm going to go have some hot wings. I've been at it since like 9 o'clock. And I've been up since 9 o'clock. So I'm just going to have some hot wings, have like a beer or something, and then just take it down and go to sleep. I'm very tired. And that, oh my God, Cody, that circular question, jeez. I was like, what? You gonna do me like that, Cody? No, I'm playing. It's all good. No, I really like the hard questions because then the fangs got to come out. The nerd fangs got to come out. You know, so, let me see, what's that say? Yeah, that was tough. I was like, whoa. When I was reading it, and I'm just sitting there like, really, Cody? No, I wasn't really. But, yeah. So I just, every week I try to demonstrate how you approach these questions. Sometimes you won't have like an approach, but just break it down line by line. I even had to reread it again because I thought they were going in the same direction on the same side. But as I reread, they were on opposite sides of the circle going in the same direction and stuff. And so I really pulled it apart. And if you guys come in late, I encourage you to go back and look at that circumference question with Sue and Joe, I think the names were, or whatever, on opposite sides of the circle. That was really, really a tough question. And, you know, for all the newcomers, I'm here every Friday from 9 to 10. And, you know, all to get the most out of this. I don't understand. I'm here. It's free. It's a live stream. You know, like, I will be here every week posting questions. and emailing me questions. Quick questions: does a plane have more or less drag at higher altitudes? I think it's just proportionate, meaning that, and if anybody is looking at Julia's question, quick question: does a plane have more or less drag at higher altitudes? I would say it has the same amount of drag at higher or lower altitudes, but that is a good question. Don't well, air density affects the plane in a couple ways. Although your atmospheric pressure as you climb atmospheric pressure gets lower, it's actually the best environment for jet engines because theoretically the molecules do spread apart, but then you have colder air as we increase altitude. And you know what? That will be actually something that's the first question I'm going to address. Or Julia, if we meet up sometime during the week, I'll go in depth. For time reasons. But initially I'm going to say no. As far as drag goes, the drag should be pretty much the same. Now you will get a reduction in thrust because of the lower atmospheric pressure. But there's a bunch of factors that play into that aerodynamically, and we don't have enough time to really dig deep. So this is something that, and please send me a reminder email about this question, because we're at the end, and I don't want to make it seem like I'm deflecting the question. If I'm deflecting the question, number one, I don't want to give you bad information because the trolls are watching. Not because the trolls are watching, but because I just don't want to give you bad information. Number one, and number two, I want a clear demonstration as to how. It's kind of like that circular question. Yeah, I did answer it, but not only do I have to answer it, but I have to make sure that everyone in the room, or my goal is to make sure everybody in the room understands it. And that's the whole purpose of me. It's like, okay, everybody type in clear if you got it. You know what I'm saying? So I want you to email me that question, please. And then this way I'll put it in next week's live stream so everybody can, I can explain it in a way that everybody can understand. Very simple and everything, and everybody walks away like, okay. All right, guys, so I'm here every week. Bring your questions. If you're going through your ASVAB, your SIFT, your AFOQT, your OAR, what else? Any Federal Aviation Administration test that you're preparing for, from private pilot all the way up to airline transfer pilot, initial instructor all the way to multi-engine instructor, basic aviation ground instructor all the way up to advanced ground instructor. I've taken to pass every test. Been there, done that. So if you have questions concerning that, bring them to the room every Friday, 9 to 10. All right. So I'm Kino, STEMwithKino.com. Really like to thank you guys for watching again. Have a great night. And here's where I do my little finger thing. Bye-bye. Hey, go away.